What's up, guys? Today we'll be doing BC Joe Academy. Today's topic: Parametic. Graphs. Okay. Well, what's there to talk about? Well, let's just say that a parametric function is some function. It's not even a function. I'll be honest. I mean, literally, it's not a function. But you have a function x that describes how the x changes, x of t, with a y coordinate of y of t. So the x and y coordinates have their own unique graphs that describe some things like motion in a 2D space, right? Imagine you're moving. You can go side to side, up and up in a matter of time, t time. You can realize, yeah, technically not a function, but like it's describing the things you've been through. You went through here, and there, and there. Right? So this is gonna be a short one. It's not much to say about it. Let's say you have the function x and x squared, or actually more specifically t and t squared. How the graph would look like would be like this. So at 1 time 1, it would be at 1. So we got 1. And for the y value, it'd also be at 1. And after 0, it would be 0. But then at 2, it would be 2. But then at 2, it would be at 4 for the y value. 1, 2, 3, 4. So then it would actually be here 3, and it would be 9. And we can just quickly graph this on Desmos. I don't feel like drawing this. It looks something like that. Obviously a parameter. Let's say that. Oh, basically a parabola. Yeah. Yeah, basically a parabola. It literally is a parabola. Because parabolas, every one step, it doubles. So you could describe a parabola in this way. If you wanted a graph like 3 over 2x, you would have to write t first and get a straight line.
Because your progress
Just get 100 negative.
Visit your nearby Cedar Sinai today.
And then we get 2, 3, because remember, y over x is slope of a function. So it's 3 over 2, you get 3 over 2 slope. And for t squared and t, well, it's just t squared and t. And if I put a 2 and 3 here, it'd be 2, 3, 3 over 2, x squared. Oops, hold on. Would it be 9? No. No. I don't know. I don't know anymore. Alright, I figured that out. It's 3/4 x. So the 2 here has to be squared and this 3 is let alone. So I'm assuming you put this 2 into this 2 and 3 into this thing and divide it. Because if I wrote different, I wrote it like 3, 3, and therefore it should be 1 to x squared, which matches what we got. But if we had t squared, let's see what that looks like. Okay. Fact of the matter is, if time was negative, it still probably looked the same. So, yeah, it's just a straight line. And it's probably, let's see, yeah, it's just y equals x. Mple was 2. Would it be 4 over 9x? No, not. Toilet. What is that? Be 3 over 2? What the hell? My bad. Oh, it just beats. Okay. So I guess those t's cancel out, I guess. Toilet. Okay. So that's basically a parametric function. It's just a combination of functions for x, y values. And it could be written in vector form that describes a vector like this. It's just a vector, and there's only a difference in when you get a derivative. Now, when you get the derivative, dy dx of this function, in terms of dy dx of the parametric function, it is equal to dy dt over dx dt. Or basically, if you cancel it, if you did the math, equal dy dx. And surprisingly, the double derivative of this d squared over dx squared equals dy dx over dx over dt. Surprisingly. Toilet. I don't exactly know why, but if you replace dy dx with this, it will cancel out to d squared dx, so that's why. So you always have to get the dx over dt of this when you get double t. I think I mentioned this earlier, but getting the derivatives of a vector is just getting the individual derivative of this function and this function. So the derivative of this would just be x prime t, y prime t. That's it. Also, by the way, when you do get the derivative, you get like an answer t equals some number, right? T equals 2. You plug in 2 back into these individual things to get the literal values at that time, but the time itself is not graphed. Because this is x, this is y of t, x of t. There is no time in this thing. Time is literally not here, other than the fact that it overlaps each other to show that there is time. Like, I'll show you. Sin x. Oops. T. Like that. I mean, also a property of this is, you know, going around. And, well, that's also how you make a circle. Yeah. Make it both sides. Let's add t. Yeah. If you had t, look at that. And let's see time. If we had t equals 1, look at the point. It's look how it jumps. Or we can label it as n and negative n. Actually, or 0 actually. Let's look at it. Starts from there. Notice how that even at 1, t is not at 1. When t is 1, it is not at 1, but in fact it's x and yt. So yeah. So that t is just a variable to tell you at that time x of t is at this position and y of t is at that position. Yeah, it looks pretty cool, huh?
Catch a nigga down bad, beat him out his jacket. Fast gang, on wet shit. Whole ass on the game, sights in the scope in the red dot.
Look at
The
that.
rats in my drip, now I look like a fat bitch. Time from the game, we don't never see wet shit. Brand new burner, got the burn on me outside. Nigga say he got more tied on cop tie.
Look at that function. That's pretty cool, huh? So that's basically parametric functions. There's not much else to it other than the derivatives, but those are kind of easy. And the questions and FRQs about it are usually about physics, motion. I'm not gonna talk about that right now. So that's the end of this Joe Academy Paramedics.